Good afternoon, ladies and gentlemen. Thank you so much for joining us. Well, before I just welcome you once again, I request everyone to please be seated. Make sure your phones are on silent mode. Thank you. I first of all welcome all the dignitaries, all the delegates, all of you. And as we all know, this is our second international conference on green hydrogen India 2024. And today we are discussing on harnessing green hydrogen through biomass based pathway. So for this, ladies and gentlemen, I would request our panelists to please join us on the stage, starting from Mr. Sumit Sarkar, our Chief Executive Officer, Chhattisgarh Biofuel Development Authority. Can we please have you, sir, on the stage? Please. तालियां तो होनी चाहिए. Can you have a round of applause, ladies and gentlemen? Thank you. May I now request Mr. Bharat Newalkar, our Chief General Manager, R&D, Bharat Petroleum Corporation Limited, to please join us on the stage. Thank you. May I now request Professor S. Dasappa, Center for Sustainable Technology, Indian Institute of Science. Thank you. And there is one more name who will be joining us in a short while, Mr. T.S. Venkatraman. He is not here right now, but he'll be joining us shortly. And now, ladies and gentlemen, our moderator for the day, may I now request Dr. Umish Srivastva, our Executive Director, AE&NEC, Indian Oil Corporation Limited. Thank you so much, and everyone knows the topic, so please get ready with all your discussion. May I now request our moderator of the day, Dr. Srivastva, to please come on the dais and please hand over the. Please, आप लोग जितने भी लोग हैं, एक बार जोरदार तालियां से before we just start the day. Thank you.
Yeah, good afternoon. Welcome to this session on harnessing hydrogen through biomass pathways. And it is often said that if you want some different results in any area of your life, you should do things differently. And I guess this is one session which actually is thinking differently out of the entire gamut of green hydrogen that is going to be discussed for the next 3 days. I think biomass-based hydrogen holds the magical potential of actually bringing, getting the viability of hydrogen, the green hydrogen, to the goalpost. And at least we at Indian Oil, and I'm sure the panel, the esteemed panel who's present here, believe so. And there are certain projects which are going on around the world. There are certain projects, certain actions which are being taken throughout. May I now welcome Mr. T.S. Venkatraman Saab to join us on the stage. This way, sir. Please. No, please come. I was just worried whether you are here.
Okay. Thank you.
So, it's my honor to be moderating this session comprising of some very learned people in the area of biomass based hydrogen research areas, the industry. We have Shri Sumit Sarkar ji, CEO, Chhattisgarh Biofuel Development Authority, Professor S. Dasappa from ISC Bangalore, Shri Bharat Newalkar Sahab, Chief General Manager, Bharat Petroleum, and now we are also joined by Shri T.S. Venkatraman, he's CMD Arvin Advanced Technologies, Chennai. So I would now request Shri Sumit Sarkar to present his views on this very pertinent topic of harnessing green hydrogen through biomass-based pathways. Whichever way is you're comfortable.
Hello, good morning. Namaskar. I think I am carrying a small presentation. If along with my speech, if that can be shown, that would be better.
Is your presentation loaded there, Sarkar sir? Is it loaded there? It's already there. How about you, sir?
Yeah.
It's loaded. Okay. You may even like to come here if you want to.
No, I'm fine. I can speak here. I think the audience, someone from there can just, if I say next, you just, okay. Yeah, so thank you very much, Dr. Umish Srivastva, my co-panelists, Dr. Venkatraman, Dr. Dasappa, and Bharat and Newalkar. It's an honor, and also by honoring me to speak fast in the entire profile. I think the entire discussion today is based on the potential of green hydrogen generation through biomass. And on the perspective of the entire country, I am only able to give you a glimpse of what we are planning on a state perspective. That is a small state of Chhattisgarh, where we are planning how to exploit the potential of harnessing green hydrogen through biomass-based pathway. And we have made an action plan for that. So the action plan is something, a kind of a roadmap, what we could achieve in next 5 years or 6 years. So just quick slide that shows how the green hydrogen standard of India and why we went into biomass related. Because the MNRE circular that says that renewable energy, anything is not limited to electrolysis or conversion of biomass, can be taken up for green hydrogen production. And we have various, if you feel, Chhattisgarh is a state endowed with 28 materials of mineral materials. And we are first in coal and dolomite production, second in iron ore production, and we are having 8% of India's limestone. So we have a large industrial units, that is, we have 23 iron and steel plants. We have aluminum plants, cement plants, and thermal power units. So initially we thought, let us target the biggest entities in the steel, where we can have some, how much they require and how much is the hydrogen requirement per year for them, and whether it would be able for us to fulfill their requirement through this green hydrogen. So technologies we have taken, two technologies we have identified. One is the normal through electrolysis, and the another one is green hydrogen produced through conversion of biomass. And in this, we have taken the technology borrowed from BARC, that is the Bhava Atomic Research Center, Mumbai. And it is a pilot plant is on the making, the process diagram, etc., all being readied. So the feedstock for such such green hydrogen from biomass. We are targeting the biodegradable waste, vegetable fruit waste, then cow dung, napier grass, as well as we are also going with pre-treated paddy straw, that is, and press mud from our sugar mills. So a pilot plant is the target green hydrogen route. We are currently jointly with BAC, we are setting up a pilot scale demo green hydrogen plant. And we already, no, I have not come to that. So coordinating, just an idea, because it is not that a single department or a ministry like MNRE or anybody can go through with production of. So it needs a very coordinated approach amongst many departments in our state, or if you say Government of India level, we have to have agriculture, industries, energy, MNRE, power, steel, many ministries come together, and then only it would be possible. And in state perspective, we are trying to do it. So what we were telling is that we are going for hydrogen from biomass. So biomass, this is the biomass availability in Chhattisgarh. More or less around 18 districts we have tried to focus here, how much is the possibility and what is the green hydrogen generation. In this technology, we are assuming that around 40% of conversion will be there. So that also we have converted into tons. And the annual biomass does not mean it is biomass. It is the surplus biomass. Because biomass is generated in huge scale, in everywhere throughout the country. But then there is it goes for fodder, it goes for some animal requirement. So after going by that, this data shows after the entire consumption, what is the potential or availability of biomass in those districts. So if you go on mapping this for the entire country, maybe all the districts have a different potential. Many are crop growing areas, many are no crop growing areas, and then kharif crop and etc. So throughout the season, you have to address both Rabi and kharif crop, how much biomass is coming out, and then how accordingly you have to plan the sustainable source for the entire calendar year. So these data are shown are all agriculture data, and we have taken up conversion methodology. And so going by biomass availability and all these, I just have a single slide showing you that how technology selection is one of the biggest challenge, how to convert the biomass. And here we have signed a technology transfer agreement with Bhava Atomic Research Center, and their Nisarguna technology developed by BAC for different biomass is coming in as help for us. We are now combining both BAC Nisarguna technology, simultaneous production of biohydrogen and as well as methane also from biomass waste. So the next step, stage 2 of R&D, already we have started. That is the prototype development of hydrogen fuel combustion engine and its trial in BS6 passenger vehicle with IIT Bhilai. Although this trial topic is not related to today's presentation, but just for your knowledge, the how, where, when, other than steel, how we can use it in vehicle. So the next stage of R&D has already started. We have, this technology, process flow, biomass-based pathway, and how the dark fermentation and methanogenesis works together. That is a technology glimpse for the viewers here and for my panelists also. Please note that the technology is patented with BARC. We have just borrowed the technology, and definitely jointly with BARC, we are trying to further improve upon it wherever there are lacunas. So we have to frame up appropriate fabricators, technology, how they are doing. So we are having a frequent collaboration nowadays with them, so that their scientists also come. We also visit. We have some fabricators who are fabricating it for us. So next slide also gives you a glimpse of the process parameters. And in the first stage where the hydrogen is coming up, So this is a combination of Nisarguna technology for hydrogen and methane generation from biomass. The biomass in the first stage, after we take out the hydrogen, the unused biomass is again utilized in the second stage for methane generation. That's I think is what from our side from Chhattisgarh. We are ready to adopt further technologies whenever we find some better technology and improve upon it in due course of time. Thank you. Namaskar.
So I propose that we'll take the question answers at the end of the session. We'll have sufficient time, and I'm sure you all would be eager to ask a few questions to each of the speakers, especially Mr. Sarkar, the innovative technology that he has just shown to us. May I now request Sri Bharat Newalkar, Chief General Manager, BPCL, to present his views on biomass, and he says, is it a potential feedstock for India-centric hydrogen production?
Yeah. Good afternoon, respected panelists and moderator, sir, and my colleagues and delegates. I'm here to give you food for thought. Not going to give much lecture, but as our moderator, sir, has told that if you want to do things differently, we have to think differently. So in that way, if you look at, first question is that, is it a potential feedstock for India to make an India-centric hydrogen production? Let us talk about it. We, EPC, IOC, HPC, we are OMCs and we are distributing energy across the nation. And we are energy distributing company. As we move on to a cleaner fuel, green fuel, hydrogen, there is a need for us to look at options to distribute this energy form in most effective and cost-effective manner. For that purpose, it is very, very important to understand how do we do it. If you look at today, the hydrogen production cost plus storage and transportation is very high. We all also know that it is about $8 to $10 per kg. It is not affordable to the people people like India. At this point of time, if you look at, we are all working into area of how to reduce the cost of production of hydrogen. However, there's a need to look at how do we look at cost reduction in the case of storage and transportation. Because there's a famous dialogue in the movie Munna Bhai MBBS. Chai se zyada kitli garam hai. Today, chai se zyada kitli garam hai. So how do you make kitli more cost effective? So if you look at that option, you look at how do we produce hydrogen in decentralized fashion, wherein we can need to storage and to transport the hydrogen. And for that purpose, what to do? We have got an option of biofuels platform. We have got CBG. We have got ethanol. Both the value chain of this CBG and ethanol are well established in India. How can you leverage that platform to make green hydrogen in decentralized fashion and look at how to distribute energy in the most effective manner? Because the Indian customer always demand kitna deti hai, kitne mein deti hai. So all these things, the questions are there for us as OMCs to answer. And we look at that, considering that point of time, what I propose now is that is a food for thought. How do we leverage biomass-derived hydrogen platform? If you look at CBG, that CBG is totally established now. We have entire framework available. What we can do is that we can look at production of hydrogen using a different technique, methane pyrolysis. If we do that, we have a byproduct hydrogen. The main product is carbon. This carbon can be utilized for making activated carbon. And it is basically, if you look at very critically, it is a CCUS. So we are producing hydrogen, plus we are doing carbon sequestration utilization. So it's an excellent platform for us to convert CBG to hydrogen by a different technique called methane pyrolysis. Why I'm saying so? Because for water electrolysis, hydrogen production takes 55 units of energy, whereas this pyrolysis method can take up to 10 units of energy. So it's going to bring down the cost. It's going to give the new business. If you look at current carbon market globally, I just got some points over here. Global activated market size is about $4.4 billion in 2023 and projected to reach $8.4 billion by 2030. It's going at a rate of 10 CAGR. This pyrolyzed carbon, which is formed in the process, is excellent feedstock for activated carbon. So we are generating revenue out of this, plus we are producing a green fuel by this process. Similarly, for steel sector, we should look at. The steel sector also goes in similar fashion. They require carbon-free hydrogen. We are very good in distributing energy, as I mentioned to you. Current Indian steel industry size is about 136 million tons in 2023. It is expected to grow to 210 million tons by 2029 with a rate of 9.18 CAGR. Here we have also got a good business case for steel industry. If we supply CBG or CNG also, they can make pyrolysis, they can do the pyrolysis, produce carbon and hydrogen, both can be consumed in their process. It's an excellent case for steel industry also. So it's a win-win for customers as well as for the producers. So this is a platform which one should target, in my opinion, to look at how to distribute energy of green energy in most cost-effective manner. Second comes is, I want to touch upon ethanol scenario. We all know that ethanol scenario is, we are doing very well. We are going to touch E20 program now by December 24. And also we are going to enhance our ethanol production capacities. The projected capacities are about 2,200 crore liters by 2026. Our demand of ethanol requirement is about 1,100 crore liters for E20 program. Plus we have got 100 crore liters for SAF program. Plus we have got 100 crore liters for our chemical industry program. So we have got surplus of ethanol. And if you look at that program, then how do we look at leveraging ethanol platform for hydrogen production? I'll give a simple case over here. Like other than we talk about many sectors like hard to abate sectors like refining, steel, mining, all these sectors. But we look at this one small percentage of sector, that is the pharma sector. They consume about 9% of the hydrogen consumption. However, they will look at very carefully. Most of pharma sectors, they export to EU and US. And they also use unsolvent ethyl acetate on their process. Ethyl acetate conventionally is formed by using hydrolysis process. And we know that today it is reacted with ethanol plus acetic acid. Acetic is imported. We have limited capacity of production of hydrogen. So if you look at, I'll just give the numbers to you. Our indigenous production of ethyl acetate of 440 TMT last year, vis-a-vis acetic acid production was only 165 TMT. So we are net importer of acetic acid to meet our demand. Can we look into a different scenario wherein we can use this ethanol to make ethyl acetate and hydrogen? In that way, we are going to help pharma sector to make their process green using green solvent ethyl acetate, plus using green hydrogen in their process to make product more green, so more sustainable, more affordable. So in this process, we require to have a catalyst which is more selective for going for ethyl acetate to aldehydes, aldehyde to, ethanol to aldehyde, aldehyde to ethyl acetate. In that form, we can help the industry to make this program more sustainable. And plus, according to this, I would like to add one more point. In case of CBG, we can also look into how do we roll out hydrogen in part manner. We can go for SCNG. In that way, you can look into SCNG program by doing partial pyrolysis of methane. We have devised a program for that. So it requires an R&D platform to develop, and we can develop this platform by leveraging our biofuel platform, which is already available to us. So with this in mind, I'd like to submit that now it is essential to look at indigenous technologies, because we got independence in 1947, but we have to get technology independence. It is essential for making us Viksit Bharat. So with this, I'll leave this forum for food of thought. Thank you.
Thank you, Mr. Newalkar, for your giveaways in this form of food for thought. I'm sure we all will be thinking, and we'll have a few questions ready for you. Now I have the pleasure of inviting Professor S. Dasappa. He comes from Indian Institute of Science, and he'll be speaking on sustainable approaches for green hydrogen production using biomass.
Yeah, thank you, Chair, for introducing into this panel what needs to be really looked at in terms of things. This is just to give you a glimpse about what is the potential. And yes, we import about 300 million tons of oil and gas together. And we have a potential of about 250 million tons of biomass, surplus biomass, which is available. You saw one of those things being stated for a given state. Here we have about 250 million tons. When I say 300 million tons of oil is being imported, it's equivalent of 300 million tons of carbon being imported too. And even if you really want to substitute that carbon, we have a potential to substitute through biomass, which is available. Surplus biomass is close to about 150 million tons of carbon is available. Plus, we have municipal solid waste and various other things. While there are various technologies which can be really looked at in terms of converting a solid fuel to gaseous species, mostly people are very much conversant with the fermentation process, biochemical process, wherein you get methane and so-called CO2, which can be further utilized. But here I would like to introduce a slightly different one, maybe some of you may be aware of. We do what we call it as thermochemical conversion process, wherein you subject to the biomass to an intense thermal treatment using reactants like steam and oxygen. You get a hydrogen-rich syngas, which about close to about 50% hydrogen and about 15% CO. And the other particulates, other parts of the entire thing is about CH4 and CO2. You capture virtually about 75 to 80% of the energy which is available in the solid as gas. Maybe in large scale we have looked at 85% too. And we have developed a small scale activity. I think some of these things to test it on the fuel cell was in collaboration with the Indian Oil Corporation, wherein we have generated the necessary gaseous species which can go to a fuel cell grade hydrogen, that is 99.97% purity, and trying to see whether what can happen to the fuel cell. That we have demonstrated. The uniqueness of this technology is it is agnostic to the kind of fuel what you have. It can have wood, it can have agro residues converted into briquettes, or it could be a coconut shell, with a very difficult fuel to handle for any thermochemical conversion, or a bamboo. A range of things can be really looked at as a fuel. Salient features is roughly, as I told you, it's agnostic to the fuel. Maybe it has a capability to handle varying ash fractions. Yes, we have done paddy straw too, but I think still some more work has to be done. Bagasse we have done, corn cobs we have done. I think some of these things can get you a gas composition which can go to a fuel cell grade. Yes, we have been looking at scalability of this And the uniqueness of these processes, like any other power plant, you can really look at about 7,000, 7,500 hours in operation in a year. That is the uniqueness of this. And we have a 5 kg per hour operational plant at IASC too. What are the transitions which we can really look at as an application? I think this is something which becomes very, very important. What we see is into a refinery, we can really inject the syngas. This syngas is sort of, if I remove CO2, it is comparable to what you get syngas from a steam methane reformer. And our intention is to see whether we will be able to really look at the syngas which goes into a reformer through this process and utilize all the other infrastructure what is available in a refinery. This makes sure that, yes, your downstream processes can be really looked at, or in an application wherein you really want to look at pure hydrogen, which can go to the refinery, can also be really looked at. Because those downstream technologies we have developed, but they are also available. I think this is one option. Second option to look at is, yes, if you really want to use hydrogen as a stored liquid organic carrier kind of thing, methanol, ethanol, because many of these processes are already done through the steam methane reformer process is a commercial process. What we want to do is whatever is required at the inlet to the process, say methanol process, we can do it from green. That means completely bio-based COH2 molecules can go into the reactor so that it becomes green. And similarly, if you really want to look at any other operations wherein you have furnaces and other things which can go into the so-called industries, yes, this can really happen into that place. For example, steel sector, we are exploring the steel sector. People have been talking about hydrogen. There is very little experience in terms of putting the complete hydrogen into the thing. They also need carbon, which is going to be playing a critical role. I think based on the discussions, yes, COH2 mixture can go into the so-called steel as a reductant, and this can make a big difference in terms of what impact it can do for the reductant there. I think many of these things are being explored to see whether we will be able to replace or at least substitute the fossil fuel which is there. For example, the word COREX process is used here. The COREX process is a process which is a patented process which generates a gas similar to this one using coal. We can really substitute that with the so-called biomass. And here is one slide, maybe this probably will trigger a little more discussions, which I think the moderator had really requested, can we put some numbers into the so-called thing. Maybe as a baseline scenario, CNG would be maybe 1.3 rupees per megajoule what we get. And if we convert that into hydrogen, it's about 1.2 rupees per megajoule kind of situation, where when we really look at about 3.5 kgs to 4 kgs per kg of natural gas, which will emit about 10 kgs of CO2. Maybe one number which we have used as a reference to this one, maybe people can debate that one, is about 350 rupees per kg coming from the electrolyzer path. I think people can debate these numbers the way we want. In the steel industry, the COREX gas, which is a reference gas, approximately is about a rupee per megajoule what goes into the application based on the COH2 what they require. Now you can see the comparison between what happens with the electrolyzer to this one. If steel industries have to go that one, in fact, steel industry says that unless until I get about $100 per ton of CO2 abated and also cost of hydrogen to be less than $2 or maybe less than $3. Is the kind of references which are being looked at. But if you really convert biomass to syngas which can go, it can be comparable to the price of what is happening currently through the large scale plants which have been put together. And maybe when we convert this into hydrogen, which I showed you as a part and parcel of hydrogen, we can really look at about 2 rupee 40 paise per megajoule, maybe looking comparable, but I think with scale and range of things can happen. Maybe these are all ballpark numbers which can get refined, can be better in terms of once we look at thermodynamics of large scale applications. I thought this probably would be very, very useful. And we also should really look at when we want to really see how steel and refinery can get into the large scale hard to abate sector. Is there a way wherein we can intervene into the policy? I think I leave it at this stage and we can take it up as we move forward. Thank you.
Thank you, Professor Dasappa, for as a back of envelope calculation. I always think that, I mean, whatever efficiencies we improve on electrolyzers, it will still require something like 30 to 40 units of electricity per kg of hydrogen. And if that has to come, I think it will always be beyond $2 per kg in the best case scenario. So that is where I say that when you do have to do get different results, we need to do things differently. And this is where I think biomass can play a role. So now I would like to introduce to this audience Shri T.S. Venkatraman, he's CMD, Esvin Advanced Technologies, who's going to talk on the utilization of thermal platform for biomass to green hydrogen. And he is especially going to talk on the gasification technology which has been developed in USA, and he's responsible to take it forward in the Indian scenario. Mr. T.S. Venkatraman, please. You'd like to speak from here? You have a presentation also. Is there a presentation already loaded? Yes. It's already loaded, so you can change. You want to go there? It's not visible from here. Okay. Okay. Yes. Oh, this is the one.
Good afternoon, ladies and gentlemen. Thank you, Chairman, allowing me to have the last word. One has dropped out, so we have enough time. What I'm going to present to you is something not very unique, very different from Dasappa. Both of us looking at biomass in a fluid-based bed gasification. Only thing I looked at it about 30 years ago and set up a demo plant for liquid biomass like black liquor and way back in 1992 or 3. So what I'm trying to tell you is we acquired a technology from USA, and the whole idea of this company is to acquire advanced technology, make it indigenous so that it's available to people now. R&D from India also should proceed because we have to do indigenization eventually. I'm glad Indian Science is taking it up in a vigorous way with Indian oil. Meanwhile, we are looking at a couple of things. We just want to show you what we are trying to do. Well, one point is just it's close to my heart as a chemical engineer is hydrogen is available in two sources, water and a biomass. I'm not taking the fossil fuels. It is bonded with oxygen in water. It is bonded with carbon in biomass. So we'll have to see how to split it. So associated with the oxygen is electrolysis, associated with the carbon is thermal gasification. So this is what finally the energy input we have to see. What kind of energy we are to introduce in order to get the hydrogen out. In electrolysis, you all know that's about 50 kilowatt hour per kg of hydrogen. So we also compared, I hope some numbers are here in the base. Okay. So we'll talk about that so that people get a real insight into what we are trying to tell. So there are two gasification. Actually, most of them all over the world is direct gasification. And also Professor Dasappa is also using kind of a direct gasification. What we do is we're trying to introduce indirect gasification. It's most dependent for gasification of biomass, considering low ash melting point. There is no commercial scale technology yet available in India. CapEx for this technology is also very high. But what we want to tell you is how this indirect gasification is very important because of the salts and also low melting ash and other things. So how we tackle that in a two-stage biomass gasification technology available in USA. I don't want to talk much about our company or about technology. I want to give you a general perspective for all of you as to why we should look at thermal platform. Our friend here is looking at fermentation platform from BRC. So BPCL has taken the first tranche of 500 tons per annum of hydrogen, right? Now like if I remember right. So we are trying to get in there. We want to go to 4,000 tons. How do you do it? Scale. What scale we do? How is economics? All that we have. So we'll got enough time. So I'll allow that more for question and time, question and hour. Typically, we are looking at biomass of higher caloric value, which are difficult to go through the fermentation route, like bamboo, bagasse, and all high lignin, especially bamboo is as good as wood with a high lignin. In fact, bamboo is higher than hardwoods, what is available in India. But bamboo thrust is being given in a very large way in Maharashtra. It's available in Assam, but it's very difficult to access. We are also trying to do a project there on biomethanol, not hydrogen. Let me rush through and see what I have here. Too much general statements are being made. So bamboo has come out of the forest several years ago. Still nothing has been done. Now states are taken up thanks to steel ministry, especially Mr. Nagendra Sinha, whom I met last year, and I promoted this idea to using biochar in the blast furnaces and also biosyn gas and DRA. We'll come to that later. So he then said, look at bamboo. Then we looked at bamboo in Maharashtra, Chandrapur, Kolhapur. So what we are trying to say is bamboo is available, but you'll have to wait because it takes about 4 years to cultivate it. So otherwise, bamboo is available only in inaccessible place. So what we have presented at the bottom is what you like to know. About 6 to 10 tons, depending on the GCV, GS2 can be produced from 100 tons of biomass, depending on its GCV and gasification technology adopted. The technology in direct gasification will be able to get the caloric value is something like 4,500 kilocalories per kg. We can get as high as 10 kg of 10%, sorry, 100 kg of hydrogen per ton of boundary ton of biomass. So this is the thing Professor Dasappa already mentioned to you. We are not very different. I think it's the PSA, amine scrubbing also we are talking about. I have to see which one is more. In fact, we need this even for methanol production. We'll have to adjust the CO2. So we are looking at both amine and PSA, not necessarily BPSA. We'll come to that later. Too many ratings here. But I hope this will be given to all of you. So I just want to highlight some more things which I already talked about. The natural salts and silica. Silica is not problem in gasification. Especially what we do is indirect gasification. We do it at low temperature followed by a high temperature. Thereby the silica can be drained out in the first stage. So in direct gasification, it has some problems which we did long time ago evaluated. 1990 to be precise. So at that time, we finally acquired this technology as an Indian license. But now this American principles have gone ahead and then put up first commercial plant based on syngas route using thermal platform using RDF. So biomass and RDF not very much different, at least for the gasifier. So we are ready to offer commercially. I'll show you a quick one here. This is a typical direct gasification, which most of you know. I want to show you a slight difference here. What we do a 2-stage. The first stage, we do at a slightly lower temperature. We feed this a flow-based bed. We are providing indirect heaters. So this provides the endothermic. That means you can maximize the syngas. Part of the heat from the biomass goes to maintain the temperature and heat for endothermic reaction. So the syngas availability comes down. So we also looked at refiring the syngas in our what is called pulse heaters, but then the syngas yield will come down. So we are looking at other options, which is we'll come to later again. So this is two-stage, in which the syngas is the second stage taken through the cyclone, and then all the unconverted carbon is burnt in a almost like a direct gasification. The oxygen and steam is also used in the first stage, so the ash gets out. So we are also trying to see how to clean the syngas. When the tar is there, we are developing a catalytic reformer for tar cracking. Right now is high temperature tar cracking with a special oxygen burner. So all this is taken care of, and that's why it's commercial. The plant is running at 500 tons per day in Nevada. So they had some teething problem. They could fix it, but then it could not proceed because the investor went ahead and trying to set up one in Indiana and one in UK. So some diversion of funds. So there is some problem with regard to funding the project further, or especially the slight cost overrun. Technology-wise, we are successful. We are in 5,000 hours. So this is some comparison we are trying to do between 600 ton per year BH2 and the equal capacity of electrolyzers. All of you are interested in looking at the bottom line. Production cost. BGS2 is 190. This is 325 electrolysis. What's the capacity? It's a very small capacity. Hydrogen generation. How much hydrogen generation per year? TPA? Yeah. Oh, 600 tons. So that comes to the smallest, like what the site program can give us. This we are trying to show you. It can be even higher. We can go as high as 4,000 tons in terms of the biomass availability and where you are putting it, because we have been into biomass for several decades because we are part of the group paper mill where I grew, and then the sugar mill where Bhagat we are using 19 megawatt fully 100% biomass based boiler. Why I'm saying is we made extensive investigation trying to find out what biomass, where to use, and we are doing several projects, especially biomethanol, bio-DME, and also mini ammonia is what we are now looking at, what I call as a distributed ammonia. So if you have distribution hydrogen, you can do with the biomass, small capacities. India also requires that distributed hydrogen. So while electrolysis and also is good because you're looking at 10,000 tons per annum, even bigger. So those are required in terms of producing hydrogen for export. But we are looking at something, our treasure here is, besides solar, is also biomass, which has somewhat taken the relegated position. So I'm going to talk to MNRE to push this much more seriously so that our friends are here. One is doing with IOCL, one is BPCL. So we are trying to see how to make this happen in a small distributed way so that mini ammonia plant, we are looking at it. We found economics are very interesting. So this is what I had to present. If there are any questions, I will take it at the question time. Thank you.
Yeah, so now when we come to the end of this, I would like to once again, I'm sure you all know also that for the industry, hydrogen is nothing new. Be it the refining industry or the fertilizer industry or any other chemical industry, hydrogen was used since very long time. The only thing is the word G has been added into it, so it becomes green hydrogen. And that's the whole conference all about.
Also for gray.
G. So I must say then it's green that we are all talking about. And that is what the whole problem in front of us. So Before I leave the floor for the audience to ask question, I'll have the first privilege of asking one question to each of the speakers. So I would like to ask to Mr. Sumit Sarkar that we in India had heard about bark as the Nisarguna technology for biogas production. What exactly you intended to mention when you said that it is also going to produce hydrogen?
Yeah, definitely. The technology developed by bark initially was for biogas production. The technology then further improved upon to provide, generate electricity through biogas production. And then the technology further improved to upload that electricity, synchronize it with the grid. So it is further development that this methanogenesis and the Nisarguna technology is now being improved upon to produce green hydrogen.
So you mean to say during the process, some hydrogen is produced and that hydrogen is getting separated?
Yes, it is in the first stage. The total process is being divided into two stages. First stage is the dark fermentation hydrogen production. And it depends upon several influential factors. However, if you control upon the pH and other things, you will have around, from the entire load of biomass, you can have around 40% of hydrogen. And after the second stage, you can have another 45% of methane and remaining CO2 and other trace gases. So it's a two-stage production. This first stage, you get the hydrogen. And in the second one, the unused biomass, that is then again taken for methane generation.
Okay. Okay, thank you. So my next question is to Shri Bharat Newalkar sahab. You discussed about the pyrolysis route of producing hydrogen. More about how it can be done.
Yeah, basically, we require to have development of pyrolyzer, which will basically using a plasma to feed have methane in plasma environment to crack methane in carbon and hydrogen. So we need to do R&D program in this direction. Simultaneously, we can parallel look into pilot and understand technology and see the effectiveness technology in Indian context. So what I feel is that MNRE should promote R&D funding in this direction also to look at cost-effective manner of production of hydrogen by plasma technology. And for that, what I want to also say that we can also look into modular plants based on plasma, so that it can be adapted for decentralized hydrogen production.
Okay, thank you. To Professor Dasappa now, I've seen his plant producing green hydrogen to the purity of PEM fuel cell requirement at IISc Bangalore. And my question to him at that point of time was the same that I'm going to ask him now, that there is always a trade-off when you have something as a proof of concept running in the lab, and then you have to scale it up, taking all the risk and uncertainties also to multiple levels. So what is the exact multiplication factor in terms of a scale up of a technology which you feel will actually give sufficient confidence to the developer of the technology, which is the innovator like you, the proponent of the technology like the MNRE, the very purpose that this conference is being organized, and to the entire world? What should be the right scale up factor? Because I understand you are producing the hydrogen at a rate of about 1 kg per hour. So what scale up do you think will be the right factor?
Yeah, thanks. I just would like to currently we are producing at around 5 kg per hour in the lab facility. But the scale up is a very, very interesting thing. See, we have used this platform which we had already developed for power generation. This technology we had deployed about 2 decades back for power generation across various industries, and also replacing oil in industrial sector. At one point of time, we were replacing about 50 tons of oil every day. And this technology, we had scaled it up to about 2 tons per hour as a single unit, and which was also evaluated across the globe. in fact, based on our global presence in terms of showcasing this technology, GE came and took the technology. And that means we have the scale up to about 2 tons per hour of biomass. It's equivalent about 150 kgs of so-called equivalent of hydrogen per hour is something which is already available, which we can really tap and take it to the next stage.
30 times.
But we have also done the necessary work over the last decade kind of things, wherein we have learned a lot more what we did 2 decades back. Today, we know what needs to be done for scaling up, and we are looking at least about 3 to 4 tons per hour capacity at a given location is what is possible. I think necessary scaling laws are available, necessary modeling and various other things which have taken place will give us the necessary impetus to take it up to a bigger scale too. I think that's all I would like to say. And it has its own, maybe some learning which has to be done at that scale. We are enabled with through various industrial houses which with whom we are interacting to deal with this situation.
Thank you. Thank you. So now my question to Shri Venkatraman Saab. You've mentioned about 2-stage gasifier. I don't recall if I've seen in your presentation that it is being operational anywhere in the world, or is it there?
No, I just said it is operational in Nevada.
Nevada.
Out of the plant, 500 tons, dry tons per day.
Okay. And
Out of RDF, they chose this technology fulcrum out of the dozen technologies they evaluated for the last 3-4 years. Then they ran for 10,000 hours of pilot plant continuously at our pilot plant in North Carolina. So the point I'm making is what we started 20 years ago, 30 years ago, we are seeing the light of the day. So it will take time. So Professor Dasappa should be given time. IOC should hold the hand, and we should do all that. We require all pathways in India to make this carbon intensity to brought down in several ways. We are addressing that. So I want to tell you, if you have any other question, I can answer that.
yeah. So now I'll open the floor for anyone of you to pose any questions. Can we have the mic there? The gentleman at the back. You also. Okay. Is there a mic there? Yeah.
Thank you, panelists. Thank you for the presentation. I am from Council on Energy, Environment and Water. We are a policy research institute. I just had one question, which was regarding the fermentation process. We see that typically these are batch processes which run in longer lead times, but there have been newer enzymes and biological catalysts that work on organic waste streams that are there in water or so. The only issue there is the scale up that's required to meet industrial demand is not really, the potential to scale is not that much because it requires extreme amounts of feedstock. So how do we counter this problem, or how do we solve for it was the question. And I leave the moderator to direct it as necessary. Thank you.
So would Mr. Sarkar like to answer this, or Professor Dasappa? Okay.
No, I think maybe the one conception related to it is batch, it's wrong. Retention times are going to be higher. Yes, these are all continuous processes today, fermentation process, because that's the reason why you have CBG coming up the way it is going to be happening. It all depends on the liquid effluent, what is going to be treated and showcased as one potential is based on the COD and other things what you have. But the kind of hydrogen what you can generate out of that waste which is going to be stream and compared to what you have in a typical biomass is orders of magnitude very different. There also you will need large volumes because chemical oxygen demand is the one which drives what is the so-called organic component which is available, which the microbes can convert that into methane what you want, or hydrogen, whatever is required. But I think the scales of operation are going to be very, very different. But biomethanation has reached some stage for certain feedstocks. If there is going to be lignaceous feedstocks a lot more, then you have some challenges.
So can we have the mic here? The gentleman in the front. Okay.
I'm Mr. Sao from the Odisha Project and Market also. I am the neighboring to Chhattisgarh also. Thanks to your presentation, I am very interested for biomass also. We are the partner of MNRE and also working in the biomass field also under the BSc project in the last 10 years back. That is a biomass utilization of a gasification. The producer gas is generated and 100 household also lighted by the 3 points of facilitation and integration of micro enterprise in through the biomass producer gases also. So now I am asking sir one question to Mr. Sarkarji. There is a stock of feeding. Suppose we are giving fast generated methane gas, other gas, hydrogen gas will be needed. The same stock can be utilized for the biomass, or new stock will be utilized. That is one question. Second question: is there any plan for promotion of biomass in the country, or promotion of the plantation, or promotion of the, or any map for in the biomass map in the country also?
Yeah, no, to reply to your query, there are 2 stages. The first stage is the same quantity of biomass. If you put in, into that process of dark fermentation, there is actually the biogas generation process has been cut into the middle, and the dark fermentation has given input has been done. So the same biomass gives you around hydrogen in the first stage, and then the surplus biomass, which is not converted, that unconverted biomass goes for the methane generation. So that methane, then again, you can take through gasifier and you can generate electricity, power, etc., everything. So, but first you take out the hydrogen, and then if you do not want to take out that hydrogen, you can have a biohydrone also. You can make a mixture of both methane and hydrogen and utilize this. That increases the efficiency of your power generators, gas generators. So obviously that is one thing. That is reply to your first query. And the number 2 is what is the plan for the entire country that better the MNRE officials present here should reply. But the biggest challenge in the entire scenario, whether we work with biomass for CBG or we work with the biomass for green hydrogen, it is the same feed that is now going for second generation ethanol. It is going for the bio CNG, and it is also going for other advanced kind of a biofuel. So when we made a trial, when we made a data that what is the surplus biomass and how much we can utilize and how much demand of steel industries can be fulfilled, simultaneously how much biogas should go to CBG, compressed biogas generation, there we find that on a state-centered data, we found that we have enough of biomass to support at least in our state, we have a large number of steel industries. So at least majority of them can be supported. Then it can go for CBG. For that, we are now planning a CBG through a mix of multi-feed operation, means the municipal solid waste and biomass, both are being utilized in the same feeder for generation of CBG. And then if whatever in excess, that should go for other 2G ethanol, or you can say we are planning for a ATJ alcohol to jet proportional also. But all this depends on how we manage the entire feed throughout the year. As I said, Kharif, Ravi, everything throughout the year. And there we are trying to develop this, go into detail by putting up, naming every district as a catchment area. And we are going to put up, shortly the order will come out, district biomass monitoring committee headed by the district collector, who will have members from agriculture and other animal husbandry, everything. So that they will now decide whether this district goes for green hydrogen or it goes for CBG, so that there should not be ultimately a fight for a sustainable source of supply of feed. And there we are also involving now that farmer producer organizations to have a direct understanding with the entrepreneur who is going to set up the plant, and that
supported by some incentives that will give
great work has already been started in around 8 districts. Plants are already lands allotted and plants setting up. 5 plants are based on a multi-feed biomass plus MSW.
So one last, what are the challenges, issues are facing by for operation?
Challenges is the collection and aggregation. That is the biggest challenge.
I think Mr. Venkatraman would also like to answer to your question. Yeah.
Not only that, more to Sarkar. So there is no real competition between if you make green hydrogen from the high lignified bamboo or bagasse compared to the low lignin rice straw, paddy straw, and napier grass that you are using. So what is the biomass you are using in Chhattisgarh?
Yeah, it is basically the kharif and rabi crop residues. It is starting from paddy to maize to all kinds of vegetables, chilies, everything. All biomass coming out from agriculture.
All agricultural waste.
All agricultural waste.
Okay, we are looking at fortunately something different from that. So we are not in competition with you.
Yeah, you can ask. Thanks to the panelists for giving such information. My name is Ashish Gupta from Bharat Petroleum. I got two, three questions now. Some part I think Mr. Sarkar is answering towards that. But one was the actually raw material, availability of raw material. No, across India, where the consumption is mainly for green hydrogen is towards refineries, steel plants, and such kind of energy intensive industry. Second is how it should be near to the consumption center because it requires a large amount of area and all that. Now, are you going to, and then the reliability of supply to the industry. See, single plant is not going to serve the purpose. You require a lot of plants. If it is not going to be near the industry, are you suggesting something like offsetting of this green hydrogen, which is going to be set up over there? And third is why green hydrogen through CBG when we are already talking about CBG, ethanol, 2G. No, I mean so many products now which are already going to get through this raw material. Why green hydrogen? Because it may be lower in the cost, but availability of raw material, I think, would be a major challenge here. And then again, what are the challenges here? See, I think somewhere with the challenges, if that can be elaborated and can be seen, is it really worthwhile to put so many CBG plants or green hydrogen plants near to the consumption center? Is it really viable? I think these are my questions, regarding.
You are directing it to someone, or these are just
directing it to
the panel?
To the panel as a whole.
Okay, so
I think that is where we are trying to declare a catchment area. The catchment area headed by a committee should now discuss and should decide actually based on the industrial requirement in that particular district, what biomass to go for, which purpose, whether it goes for CVG or such a thing. And then also CBG plus the next stage of CBG, as Dr. Saab was telling, to go again for green hydrogen, that is a value addition to the entire chain of CBG production. So that also is very much encouraging in our state. And the how to ensure that sustainable, as you were telling, how to ensure that that is a completely a state subject. The state government is now working. Look, our basic aim is that we have to create more and more, generate more income for the farmers, villagers in the rural areas. So if their surplus biomass comes for a purposeful use for the benefit of the entire industry as a whole for the country, why not? We will definitely working. We are mobilizing our agriculture department, our panchayat and rural development department, as well as the district administration as a whole, sensitizing them that it is not that the farmers waste this, burn it or something do with this. Let us use it purposefully and gain some additional income from the surplus biomass. Challenge is definitely there, but field work and groundwork is one thing that is going on in the states itself, not only in my state, in elsewhere in Punjab, Uttar Pradesh, everywhere it is being carried out. Our policy decisions helps and supports that comes from the center. So it's a going together all the way to ensure that biomass, whatever is generated, is routed to the production unit. Anything else you can add?
Yeah. To answer your question, also complement to what he said. There is no real competition biomass. Especially we go segregate the fermentation platform and thermal platform. So the government doesn't have to do, the technology does it. So those who can use that, paper, gas, agriculture residue, all this, please go ahead. Because those are all low caloric value. So we chose what we think is ideal for the making hydrogen. Secondly, my fundamental question to Sarkar, have you looked at what is the cost of hydrogen from converting to CBG? CBG already is very high price. Finally, how many rupees per kg you think what is your target?
As far as conversion to CBG, I think that the entrepreneurs who are coming, they can reply to that. But obviously, the MSW plus CBG and solely MSW is economical to them. That is as per the detailed feasibility report carried out for setting up CBG plants in 2 districts of Chhattisgarh have been carried out by PSUs. So we are thinking that since the IRR and the return, everything is good. I will not go into detail of whatever the rate has come or whatever has come, but it's a beneficial project for the OMCs, and that is why they are coming and investing in our state.
Okay, so your question, please.
One more point I want to add here is that look at this hydrogen from methane. In mobility sector, everybody talked about scope 1, scope 2 emissions. We don't talk about scope 3 emissions. As a net zero country by 2070, we have to look at scope 3 emissions also. And converting that methane to hydrogen not only gives opportunity for CCUS, but also for reduction of scope 3. So that way it has a value to look into that aspect.
Yeah, you can ask your question. I think this is one of the last questions we'll take.
I am N.K. Sehgal from PECMA Air Systems. We are basically taking turnkey projects for conversion of the biomass to the CBG and other recovery of the CO2. And we have done a lot of work with the IOCL and R&D projects we have done for the recovery of the CO2. The question is, like at present, we are working on the dark fermentation process where we are talking about the generation of the green hydrogen, and we are doing one pilot project. We are giving a complete turnkey solution to the Delhi College of Engineering. My question is when we talk about the dark fermentation, over there in naturally it is at a first stage, and the technology to be adopted for the dark fermentation for the recovery of the hydrogen is totally different from the fermentation process, because we have to talk about number of other technologies like photosynthesis or some sort of a thermal heating or some sort of a enzymes production. My question is when we are talking about all the oil companies and all, when we are setting up of the CBG plants, and if you find all the CBG plants, none of the CBG plant is working as per the design factors because of lot of problem. Because the main problem which the issue which I am facing is that is the recovery of the CO2 or the recovery of the 98% of the your methane. So in various processes, when we talk about the VPSA or so and so, there are a lot of number of the your methane losses about 25% or 30% or even more. So our focus should be like development of the technology where we should talk about the 100% recovery of the CO2 and utilization, so that we can have a minimum payback period of the system. That is a general process. But my question for the dark fermentation is, what type of the technologies you are offering to the users or to the industries, so that we should generate the green hydrogen.
Sir, as I said in the presentation also, the technology is owned by BARC, but jointly with us, they are also improving upon it. You are correct, dark fermentation is a complete different technique which has been introduced in between the biomass and the methane. And it has got several influential factors. And all these influential factors ultimately aim towards maintaining the pH, low pH. So how this has been done, what catalysts and enzymes have been done, that has already been developed. And pilot plant, once it is ready, we can talk offline and you can come and visit and see practically how it is producing.
We need to work a lot on this dark fermentation area, which
I
need a
think-
lot of.
Yes, yes.
I think we are running short of time. There's one last question the lady wants to ask.
Thank you so much, sir. Actually, I have a question to Sumit, sir. Because this dark fermentation, I have worked a lot with Professor Debabrata Das in IIT Kharagpur. He has a very big plant developed for biohydrogen. And we had a plan to convert it into the methane also after hydrogen production. So the similar like Nisarguna, there is a plan to convert the volatile fatty acid to methane. So we can completely utilize the biomass to hydrogen and then volatile fatty acids, and we can get the methane from the volatile fatty acids. So it's not only the use of the unutilized biomass, it is the complete utilization of the biomass. So you are just talking about the Nisarguna. So how their volatile fatty acids can be utilized for further use?
Yeah, this is a detailed question about the technology, but if your technology allows that volatile fatty acids can also be taken, basically, Chhattisgarh, we are everyday learning, we are everyday developing, and we have a association and a MOU, live MOU with the IIT Bhilai.
Okay.
So what I will do, once I go back, I will ask the IIT people to talk to you at IIT Kharagpur. And we are ready, If some further improvement, value addition in the process that we have adopted through IIT's interference is, you are most welcome. I will try to take up with the concern.
Okay, thank you so much.
So I must now thank each and every one of you for being present here. It's always so much pleasure to see a hall full of audience, especially my thanks to the people who are standing there because they took the pain of being there, standing and being part of this session, and all the other people who are here, all the panelists who contributed their experiences with each one of us. I'm sure there are so many other questions that I can see somebody requesting very earnestly to me to give her an opportunity, but I would say that once the session is over, you can always catch hold of them and talk to them as much as you want. And I'm sure they're also equally eager to talk to you all. So thank you very much for being present in this session, and over to the organizers now.
Thank you, everybody. Well, now, ladies and gentlemen, I would request our moderator, Dr. Srivastva, to please proceed with the mementos. We have some token of love, or I would say token of thanks to all the panelists. So I will request Dr. Srivastva to please take over this. Thank you.
You can read from here the names and then tell them when the mementos. Can we have the mementos?
Sumit, sir?
To Mr. Sarkar. Yeah.
All right, so I would request Dr. Srivastva to please hand it over to Sri Sumit Sarkar, sir. Can we please have you, sir? Can I please request everybody to please put your hands up? Let us all thank Mr. Sarkar. Thank you for being here, sir. May I now request Professor Dasappa, sir, to please be on the stage? Can I please request you once again? Thank you. May I now request Sri Bharat sir to please come up on the stage. Zordar taaliyan ho jaye. And now T.S. Venkatraman sir, can we please have you in the center, sir? Thank you so much for taking out the time. Thank you for the discussion. Thank you for everything. How was it? Did you guys enjoy? Gathered all the knowledge, all sorted. किसी के सवाल जवाब रह गए? बाद में करते हैं. So thank you, ladies and gentlemen. I think we are over with the session and we'll rejoin in. in this hall for next session. Meanwhile, yeah. Can we have a group picture?
Take one for me, so I'll take for myself if you wanna know.
I think yes. He needs an applause too, ladies and gentlemen, please. Thank you, Dr. Srivastva.
And then we
So, ladies and gentlemen, we have the next session by 2:45 p.m. I request everyone to please rejoin in. Thank you so much. I guess PPT you need to ask. I'm not sure.